So in this video, we will study convergence or divergence of geometric series. So we know the general formula for a geometric sequence is A, first term, times the ratio to the n minus 1 power. Okay, so if we add up all these sequence, so from n from 1 to infinity, we get a geometric series. So for that geometric series, we have a formula for the partial sum. Okay, so what is the partial sum S of k? To derive it is not too hard. Okay, you do S of k, and then you do A times S of k, and then subtract each other. Maybe I can write out. So A plus A times R plus A times R squared, and so on all the way to A times R to the n minus 1 power, k minus 1 power. So that's S of k. But if we multiply both sides by A, we get S, or multiply both sides by R. Okay, so we get R times S of k, we get A times R plus A times R squared, and so on, plus A times R to the k's power. Then we notice, okay, this and that are the same, this and that are the same, and so on. So if we subtract the top from the bottom, we get 1 minus R times S of k will equals the top subtract the bottom, right? So you get A that is left, and then you subtract the last term, so A times R to the k's power. So in that case, you simplify. You get S of k will equals, you factor out the A, you get 1 minus R to the k's power divided by 1 minus R. And R here is a ratio. And R should not equals 1, because when R equals 1, so this is when R not equals 1, then you can divide both sides by 1 minus R. But if R equals 1, you just get S of k equals A. You add A how many times? K times. And as long as A is greater than 0, as k goes to infinity, k goes to infinity. So that is already divergent, okay? But for a general case, right, when R is not equals 1, R can be greater than 1, R can be less than 1, R can be negative. So how do we discuss the convergence? So that's how we have, okay, we have to focus on this term. Because only in here, k goes to infinity will affect what number you get. So that's why we have this definition, or you're trying to understand why that's the case. So if the absolute value of R is less than 1, the series will converge. Why? Well, R to the k's power, as k goes to infinity, R is a decimal number, like 0 point something. You keep raising it to the power, it only getting closer and closer to 0. So the series n from 1 to infinity, this geometric series, will just converge to A times 1 minus 0, which is A, divided by 1 minus R, okay? If the absolute value of R is greater than or equal to 1, the series divergence. Okay, we already talked about when r equals 1 is a times k, but when r is greater than 1, right? So let's say 2 or negative 2 to the k's power is getting bigger and bigger, and it's infinity on the top. The bottom is 1 minus r is always fixed. So we get divergence when the absolute value of the ratio is greater than or equals to 1. So that is the discussion about the divergence or convergence of the geometric theory. So based on that discussion, we can take a look at example 5.9, okay? Part A, we take a look at some example to see how we apply that discussion into each case. So we have negative 3 to the n minus or n plus 1 power divided by 4 to the n minus 1 power. So if we have to write out, okay, we have to change it to the form n equals 1 to infinity a times r to the n minus 1 power. How do we get that answer, right? So we have to figure out what's the ratio. The ratio is something to the n minus 1 power. We have here n minus 1, 4 to the n minus 1 power. On the top, negative 3 to the n plus 1 power is the same as negative 3 squared times negative 3 to the n minus 1 power, right? Because 2 plus n minus 1 is n plus 1. You add the exponent when you multiply. So then you get 4 to the n minus 1 power. So that theory you can rewrite as 9 times negative 3 over 4 to the n minus 1 power. Then we can see what is A. A is 9. There's a typo in the textbook. And R is negative 3 over 4. Okay? We don't care about what A is anyways. We care about what R is. It's the absolute value of negative 3 over 4. Absolute value of our R is less than 1. So we say this theory converge. And this theory converge to, okay, so this negative 3 to the n plus 1 divided by 4 to the n minus 1. It converges to A, which is 9, divided by 1 minus, so 1 plus 3 over 4. In that case, you can do your calculation. You get 36 over 7. So that is part A. What about part B? We have this theory n from 1 to infinity. E to the 2n's power. Okay. Again, we want to see this form, right? N from 1 to infinity. A number times a ratio raised to the n minus 1 power. So we have 2n. But we can n from 1 to infinity. E to the 2n is the same as e squared to the n's power. Okay? So we're pretty close to n something to the n minus 1 power. How do we get n minus 1? We subtract 1 and we add 1. Okay, so what we have is n equals 1 to infinity. E squared to the n minus 1 power. But when we add 1, it's the same as multiply by e squared. Right, so add 1 is the same as multiplied by e squared. So now we have our a, which is e squared, and we have our r is e squared. Because absolute value of r, e squared, what is e? If you don't know, use a calculator, e squared. You get a number greater than 1. So you call the series diverge.